Alright, this is probably going to be a little bit of a longer episode because I'm going to create two fairly complicated scripts. The first is a Hacknet script, and the second is going to be a stock market script. And here's hoping they work. So we're going to create a new script called hnet full. And we're going to need a few functions. We're going to need player for sure. We're going to get a couple of args. Let's call it runtime. And we're going to get a start time, which is when we spawn the script. We're going to do while time is less than start time plus runtime. So this will just keep track of the time. Every time it comes back around the loop, it'll check the time, and if it's less than start time plus runtime, so start time is going to be an integer value. What this function returns is an integer. That's the number of seconds since 1970, January 1st. It looks like that. Milliseconds, actually. So when we send in a runtime, actually, we probably need to, since we don't want to do milliseconds, yeah, so if we send in our runtime in seconds, this will convert it into milliseconds. So while time, which is another integer that looks like that, is less than that plus, let's say, like 30 or 20,000. So if we send in 20 as 20 seconds, it'll be like, well, that number is less than that number, right? Get the new time. We'll sleep for a second, millisecond, and then we got to do some stuff. We got to buy some stuff. The first thing to do is to say we don't have any Hacknet nodes. Let's just purchase one. That should be less than. So we'll just sleep if we don't have enough money. And when we do have enough money, we'll purchase a node. Okay, and the next thing we're going to want to do is probably iterate through our nodes. Trying to think how to best structure this. Well, let's get our costs first. There we go. What else is there? I think that's it. Level RAM, core, and then node purchase cost. We could do something called destructuring this. To do that, you go RAM cores production, because get node stats returns a node stats object which has the following properties: level, RAM, cores, and production. If you write it like this, it actually splits those out, destructures them into a variable called level, one called RAM, one called cores, one called production. From here, I want to calculate now. I know there are equations in the source. I'm about to look them up. Basically, the logic that I'm trying to achieve is I want to figure out what the most profitable upgrade would be. It would be most profitable to upgrade the level of a node, the number of cores, the amount of RAM, and so on and so forth. And I think I do that by, you basically want to find like a common value between all those, and I think we can get to that common value by dollars per second. I think that is the common value. How many dollars per second will a level cost increases by? How much will a RAM cost increases by? So let's say let level value equals, I'm gonna have to go and find the source. I don't have this. All right. We got a inline function here called getProd, get production. It returns level times 1.5 times mathpal 1.035 and so on. This is essentially the production of a node. Like getProd, if we pass in a node's stats, getProd will tell us how much money it makes per second. So now we just got to pass in level plus 1, because we've got these variables here, level, RAM, and cores. And we'll just ask what happens if we add 1 to each of them. That's simple. We're going to need an array sitting somewhere out here. And we want to push to that array what? Maybe something that says value, level value, cost, level cost, and then the node index. And we'll just duplicate that. We're pushing 3 values to the array, or 3 objects to the array: level cost, level value, RAM cost, RAM value, core cost, core value. And then we want to compare these. How are we going to do that? We probably need another variable here. Call it type. We know that what we're looking at later is actually a RAM upgrade or a level upgrade or whatever. Oh, what am I doing? So we're going to take that array. Actually, this is going to happen outside that for loop. We're going to sort that array by value. So which of these functions increases our value the most, I think. I'm actually not sure if this is going to give us what we want, because we should be dividing it by the cost. We want dollars earned per dollar spent, not necessarily just dollars earned. That seems better. And let's just print best upgrade. Let's see if this works. Nothing happened. We do have Hacknet scripts. I mean, we do have servers that we got from the other script. I need to use production somewhere. Oh, you know what? The problem is runtime. If I don't send a runtime, it never runs. So I want to send a runtime. Well, if I don't send a runtime, I want the runtime to be infinity. Let's just say. That's close enough to infinity. That's like 20 years. Dying. Why is it just dying? Let's try sending in a runtime. Still just dying. Never even getting inside the loop. Oh, that'll do it. Okay. So that's just looping through index 0. We have 8 nodes. That should definitely be sending more than just index 0. Oh, it's only sending the best upgrade. Instead of that, let's increase this. And we'll take off the 0 just to make sure that everything looks ordered. All right, so there's the loop. And the first one has a ratio of 0.2598, 0.2522. Okay, so that's in order. It's got the best ratio first, and the ratio is value over cost. So it's saying the best node to upgrade would be node 0, and to upgrade the level. That checks out. Or does it? Yeah, I guess you would think this would be the best thing to upgrade. Or this one, 7, because it's cheaper to get 1.5. For some reason saying the value is only 15. Oh, that's the current value. Now that's the next value. That's if you upgrade it, it will be at 15. Right, so that's this guy. That's not what we want. We don't care about that. We want to know what this value is, 1.5. See what this tells us. And now it's saying upgrade 7, and then it doesn't care which one. And the value is 1.5. That's the increase in value. And the increase in value for getting RAM is like 0.73. And it's 0.73 because the level is higher. And if we check over here and check RAM, yeah, that's 0.735, that's 0.682, even though they cost the same. Okay, so that checks out. And there's one more thing in here that we got to do. Which is multiply this by player hnet multipliers.production. Not actually sure how much of a difference that made. Still tells us to upgrade 7, which makes sense. Let's go on and click upgrade on 7, see what changes. Yeah, still telling us to upgrade 7 because it's still the lowest. The costed update. I'm getting pretty satisfied with this actually. Okay, so we know the cost to upgrade. Same thing as above. I'm just now remembering we didn't do anything with purchase nodes. Upgrade what? There we go, now we're talking. No, we don't need production in here. This probably doesn't even need to be in the loop. Okay, so the problem with this is that this is not entirely accurate. The cost of a node is high. This will essentially never purchase nodes, but the value of a node is not the value of node value. Node value is nothing. It's get prod 111. We need to actually adjust node value. How are we going to do that? Well, we could define it as the value of our weakest node. Assuming that we could very quickly get to that level. That wouldn't be accurate because it would have a cost associated with it. Honestly, for now, I'm just going to call it 10, 10, 10, or 10, 1, 1. Let's see if this buys shit. Before I do this, let me see if I can upgrade. Yeah, let's upgrade that once. Where I go and burn all my money. Well, look at that, our money's getting burned. Or our upgrades getting purchased in the best plot. Yeah, looks like we're going 21, 22, 23. Beautiful. Going very slow. There we go, and it actually purchased a new node, and it purchased another node. And it's upgrading RAM, and it's upgrading cores. I think we got a working script. Yeah, that makes sense, because you know, if you're paying $60K to get 2.54 dollars per second, but a new node is 7 times that cost. You're gonna end up buying a new node, just to get that initial, you know, boost. So I don't think the hard-coded values, I mean, they're not accurate. Obviously, you would want to do some kind of calculus to derive the accurate value of a node. This seems like it's working pretty good. Like, worst case scenario, it's a little bit inefficient. It's interesting how it jumps from, you know, when it hits 8 gigs and 3 cores, it'll only go up to level 122, but if it doesn't have those, it's not willing to go up to 116 even. I imagine it's going to get a core next, So if we wait for just a few seconds till it hits 740, I'm just going to get a core. It's going to very quickly get RAM and very quickly jump to level up. Here's the core. What I'm really waiting for is to see if it jumps the level up to like 117. Maybe even it goes to 122. Because that added core makes every level more valuable. See, this is plus 1.94, and that's 2.217. So because we've got the core, we can go and invest in the levels. Yeah, I think that's a perfect efficiency Hacknet script. I wouldn't change a thing. That's done. We'll end the video here. It's going on a little bit long, and we'll look at stock markets in the next one.